All right. Hello, everyone. How's it going? Thanks for joining us on a Friday. Bit of a washed out Friday. Well, yesterday was a lot worse. Hope everyone's doing all right. I think everyone's starting to get a little bit exhausted, but we're almost there. Only a few more weeks to go. So exciting. Maybe. There you go. My dogs also think that that's exciting. So we've got a few little plans for the next few weeks to hopefully make it a bit more pleasant for you to start finishing up your assignment or starting your assignment. So I just wanted to let you know today, and then I'll post about it as well in announcements. But what we're hoping to do is we're hoping to run little group sessions in addition to our normal help sessions, and those little group sessions will be sort of, helping you get started with stage 1 targeted, or helping you get started with stage 2 targeted, and so on and so forth. And we'll announce those on Monday when I do my announcement. And our normal help sessions, we're going to also cater lots of the help sessions to particular stages. So if you're at a particular stage, you'll log into that help session to hopefully make sure that everyone gets seen, and also to make sure that everyone is able to get through stage 1 and stage 2 of the assignment as well. So hopefully that will help, and we would love your feedback as well. I know the help sessions get very busy, so it'll be nice to see if that will actually help to relieve some of the pressure on the help sessions, and also to make sure that you get seen as well. Okay, what else? Friday afternoon, 3:05, I guess it's time to start. This is going to be, I was going to say it's going to be your last Friday. You actually even get a break next Friday. There is no lecture because it's a public holiday. So how exciting is that? So just Tuesday next week, and hopefully we'll cover kind of new content, but it's not really new. You'll see next week, but it's not like it's not going to be. And then week 10, we're not really going to be covering any new content in week 10. Week 10, we're just going to talk about the exam, and we're going to do examples and revision. Okay, so week 10, you only really have today's lecture, which is more linked lists and putting it all together and stuff. And then on Tuesday, you're going to have a lecture that's going to have a bit of new stuff. But using all the concepts that we've already done. So it's not going to be, just the idea is going to be new, but the syntax will be very similar. And then week 10 is our revision and getting through things. So there is no catch up for the Friday lecture. And the reason for that is, instead of that catch up for the Friday lecture, I feel like I have piled you full of information and concepts. And I think, it's sort of bursting at the seams. So instead of that catch-up lecture, what we're going to do is in week 11, we plan to run revision classes as you prepare for your exam. And all that's going to be is it's going to be just revision exercises, either online or in person. You come in, and we help you get through it. The exam is on Monday of week 12. It's on the 2nd of May, 1 p.m., okay? So hopefully that means, so then there's like the week 10 and week 11 will just be focusing on the exam and the revision, and just kind of, also because you have your assignment due as well, it would be a bit harsh to just be like, hey, so surprise, there's going to be 3 lectures. No, but there isn't, okay? No, definitely no 3 lectures. That's madness. So hopefully that will be a bit helpful to also, continue to move through your assignment as well. And then maybe even have a day off before you start your exams. Why is the exam 6 hours long? The exam is 6 hours long in case there's any technical issues, in case you need to contact us. So you have 6 hours in which to do the exam. You don't have to take the whole 6 hours. Okay, you can, the exam is really like a 3 to 4 hour sort of exam, but, and I'll talk more about it in week 10, okay? Not just code problems. There's going to be some short answer questions that, where you have to kind of read code and maybe interpret it as well. And we will talk about it more. And also we will make a whole bunch of questions available to you, so you can see what the questions are like. They're going to be very similar as well. Honestly, we don't want to trick you. We don't want to like trip you up in this course. So, the difficulty will be very similar. The questions will be very similar to the ones that you've done in the labs, and so on and so forth. Is the exam difficult? Part of the exam is very difficult, and you're not expected to attempt it unless you kind of want to get a HD in the course. So we will talk more about that in week 10. It's open book. You are able to refer to, our lectures or whatever else that you need to do. And if you want to utilize the whole 6 hours, you absolutely can. But please, please, please remember to, take small breaks at least, have snacks, water, no naps, maybe no naps. Will the exam have auto tests? Yes, it will. Although as you get up to the further questions, just like for our labs, the number of auto tests reduces. But for those first 4 questions in which there are hurdles, there's quite significant auto tests so that you are able to, get through it. Is the most difficult part of the exam on the same caliber as the 3 dot? No, there is one question that is beyond that 3 dot difficulty. And that question has only appeared since we've gone online to make you feel better. Look, if you can do the 1 dot exercises and if you can do some of the 2 dot exercises, you should be able to pass the exam, okay? And we'll talk more about it in week 10. We'll practice some more problems. Please, feel confident, and also you need to study. You will need to study. I can't really remove that requirement. You just like most other things at uni, you'll need to study. And by study, I mean you really need to do revision questions to actually code. Yeah. There's partial marks in the exam, so I suggest attempting questions, and as well as that, if you get, you don't pass any auto tests, but you still have some code that might compile, we mark them manually as well. We look at the exam questions to see if you would have been able to compile and run it if you're close to getting a solution. So there's that as well. So there's partial marks, okay? Yeah, that's right. So and I'll break it down further in week 10. Don't worry. Will you be marked for style? You will not be marked for style. But if I'm manually marking your code, okay, please make it nice, because otherwise it takes me forever to read it, and it makes me very there's a lot of exams. There's, the cohort is very large. I can't be spending 15 minutes per exam. So just make sure you might not have, the perfect style, but please make sure that, you have indentation. If you don't have indentation, I will probably lose my mind trying to decipher what you're trying to say. So we don't mark the style, but it's important for you to have good style so that we can read it. Yeah. Okay, awesome. And when will you receive assignment 1 marks? In week 9, that's right. So we're aiming for very early week 9, and so far I think we're on track, so that should be okay. And I'll confirm on Monday in my announcement whether it's going to be released on Monday or not. Don't worry about the exam. I will be talking in detail about the exam after the Easter break in the lecture. I will actually be discussing it in detail. I'll tell you, no, it's okay. I will discuss the exam in detail in that Tuesday lecture of week 10. I'll go through what the questions are like. I'll go through all the conditions. I'll go through all the hints and tips. There you go. My dog agrees. We will go through it all. Don't worry, in great detail. I will not leave you stranded for the exam. Okay, there's going to, and what you will get past exam, you'll get a, most of the subset of a past exam, okay? So you'll be able to see what the difficulty is like. Yeah, in like 2 minutes, you'll see the dogs trying to scratch at the door to get back in. Someone had just come into the house, which is why they wanted out, and then... hey, the dogs they do want to do linked lists. They've slept through the last 2 lectures of linked lists, so that's how they feel about linked lists. Okay, dogs are scared of exams. I don't know if dogs care about exams. You know, they don't really have to achieve anything. They get fed, they get walked, they get to sleep whenever they want. It's, you know, it's a dog's life. All right, excellent. And again, I will talk, honestly, like one whole lecture I'll talk about the exam, okay? It's just going to be like a super fun lecture. We'll talk the exam. You can ask me any questions you want about the exam, except what are the questions in the exam. And sorry, yes, okay, let me see, is there anything else? Yeah, so I think I've mentioned it before, the hurdles, they cause people a lot of anxiety, but you'll be able to get through the hurdles. Okay, in last term we had, you know, I think it was 3 people that didn't pass the hurdles and 2 of them did not attempt the exam. So you should be able to attempt one of the hurdles because you just have to pass the hurdle. You can ask about the answers. Yeah, I didn't work that very well. Any secret mark for exam? I don't know if we want to rickroll you in the exam as well. Okay, and you missed 2 lectures. Do I still have hope? Of course you do. Yeah, just watch the lectures, you know, when you have time. You've got plenty of hope. And we're about to go back to our ice cream shop. Oh, there you go. One of the dogs is back in. See? As soon as I said we're about to do linked lists, the dog was like, I've got to get in here for this. So the dogs do, in fact, love linked lists. There's another one, you see? Everyone's gathering for the linked list lecture. It's all the excitement of linked lists. Okay, excellent. Is there going to be an Easter egg in the exam? Oh, we used to have like people's tutors' pet pictures and stuff if people wanted to see them. But I don't know, a bit distracting. I guess it's a 6-hour exam. Anyway, we'll see. Maybe we'll play something in to give you a little break. We'll see how we're going. Okay, so what are my dogs' names? Jax and Juno. They're big dogs. Big dogs that should be herding sheep. Instead, they just sleep. Okay, so let's do it. So last time we did deleting from linked list. So we did 4 cases, and I said to you, you got to be very careful. Today, I'm going to make a case where we're going to make a mistake, so that you can see why we need to consider some of these cases. Okay, so I'm going to kind of stuff up a condition so we can see why it's important to consider it, and then we can draw it out and see what's going on. So we talked about when there's nothing to delete. So we talked about when it's an empty list, what do? We talked about when we're deleting at the head of the list. So we will perhaps get a new head of the list. Well, we'll definitely get a new head of the list because the head is going to be deleted. We talked about what happens when we delete at the tail of the list. And we talked about what happens when we delete somewhere in the middle between 2 perfect nodes. And then, you know, everything is very, neat and very, very nicely done. So today we're going to go back to the ice cream shop example. I'm actually going to rehash it because we didn't get very far into it because we got so excited about deleting nodes. And then we're going to build up on it a little bit. So I'm going to, we're going to build up to delete things as well in that example. I'm going to talk about a leak check command because I haven't given you that command yet. And I think some of you may have heard about the leak check, but we're going to do it. All that the leak check command does is check that you freed all the memory that you've mallocked. So it's quite useful if you compile with that command. It'll tell you when you potentially forgot to free something, and we'll talk about it in an example as well. And then I wanted to talk about multi-file projects. So I've been wanting to do this for, I think, a week and a half. And then I was like, no, linked lists, they take precedence. So today we're actually going to do a multi-file project. Very basic. It will be a little bit of a break to your brains for the Friday afternoon, I hope. So hopefully we can do that. Oh my God, yeah, my camera's on the wrong side. Apologies. I'm using the wrong camera. Here we go. Oh, and there was 2 of me for a second, and now back to 1 of me. Okay, so that's what we're going to be doing today. Yeah, it's all right, Daniel. Left, right. Yeah, that's speaking my language. Which way is left? Which way is right? Okay, lecture code, where can it be found? Tammy, if you can please post the lecture code in the chat again. So it's me and Tammy again today. Please feel free to ask questions. We're both on the same account, just to confuse you. So no problem. Okay, let's return to the ice cream shop. And what I've done is I've also drawn it up nicely, not just me drawing it up on my iPad, because Tammy kept telling me that it looks weird when I'm drawing on the iPad too much, because there's a little bit of a lag and then it looks like I'm just making magic boxes everywhere. So hopefully that will help a little bit, and then we'll go back to magic boxes, because as we discovered on Tuesday, I'm terrible at drawing with the trackpad. I really need the pen. I'm clearly not that talented at just trackpad drawing. Okay, so on Tuesday we started doing this example that was an ice cream shop, and the reason I kind of did it that way was so that it was similarly structured to the assignment 2, the way you would start your first stage and so on and so forth, and a similar structure where you have your flights, and then you have the different airports attached coming out of the flight. Okay, so I've decided to run an ice cream shop. I want to create a program that can take in all the flavors of ice cream that I have to offer by adding them to the end of the list. So each time you're appending to the end of the list, and then I want to be able to print out the flavors. So I'll be traversing the list and printing out every single element in that list. I then want to add the flavors in alphabetical order, just because I felt like we should do something complicated. Could be fun. You could hate me. Could be a terrible idea for a Friday afternoon, but there we have it. We're committed now. And then we're going to delete some flavors as we perhaps finish them, or, if we decide to delete a flavor. Okay. And in the starter code that I had provided, you had 2 structs. The first of those was a struct shop, and it had inside it a struct ice cream pointer. So a variable called flavor of type struct ice cream pointer. So that means it pointed to the address of a struct ice cream. And the struct ice cream had the structure where it had an int number, a char name of a char name array, so a string, and then it also had this struct ice cream next flavor. So it was a linked list node, really, because it's got a next item. So it's definitely a linked list node then. So what this meant, this type of structure, is that we had our shop. So our struct shop is up here. It's just got one thing in it. It's got a struct ice cream, and it's called flavor. And then that is actually the head of the list. So this is the head of the list of these ice creams there. So usually we have done just a one list, not a list in a list. And what you can't access the slides. I probably made a mistake somewhere when I made them available. Probably called it something different to what it actually is. I will fix it. Sorry, there's not a huge amount on the slides today. I'll fix it. A 404 error. Okay, clearly I've done something wrong. So these are the only 2 slides before the break, and I'll fix it in the break. Unless Tammy would like to look at the config file, Tammy. I don't know if you want to. But if you don't, I will fix it in the break. So then the head of the list are stored inside here. Instead of our just normal head of the list is just a pointer, and then it goes to here. So the pointer for the head of the list is actually just sitting inside the shop. Okay, so that's just a slightly different structure, because sometimes you have a struct in a struct in a struct, and you can keep going, right? So all that's important to know is that your head of the list is actually sitting inside this pointer here, okay? Okay, and then your ice cream struct is just your int number, your string, and then your next flavor. So then it will go on to the next one, and the next one, and the next one, and the next one. All right, excellent. Let's move on to the code then. Actually, Tammy, could you just run a little poll for me to see to see if this struct in a struct makes sense for where the head is. Thanks, Tammy. Okay, so it seems the slides seem to be working. Okay, great. Because yeah, a few weeks ago I actually took down the whole website for about 10 minutes because I by accident forgot to close an inverted comma, obviously. Yes, so this is a similar setup to assignment 2, okay? Which is why I wanted to do this example, which might seem convoluted because it slightly is for what, my example is smaller, but I wanted to do it so that it's similar to how your assignment is set up. Now, your assignment doesn't just have the head of the list inside that top bit flight, it also has the tail of the list in it, okay? So basically, Jeffrey, it depends, okay? It could be a really good approach and it depends on what the problem is. So it depends what the context is of the situation that you're providing. Sometimes it makes a lot of sense to have this type of structure because it actually allows you to kind of contextually, visualize what's going on. So ice cream sit inside a shop, which is why I kind of put the head in the shop. But before I did that, I went through like 5 different examples that I also discarded because it didn't make sense to have a struct in a struct. And yeah, so does this allow different shops? So you could carry this example further by adding, more shops in here, by having this. So I only have the ice creams, I only have one shop. But yeah, absolutely, you could extend this to have multiple shops that each have their own flavor as well. So yeah, absolutely, you could do that. And similarly, oh, look at that. And similarly, like you would for your assignment as well, you could have different flights then as well if you wanted to, which would have different airports as well. So the thing is, you could set up a struct pointer called the head to record the head. And the reason that we're doing it like this is also to show you that your head doesn't necessarily just magically appear for one list. Sometimes you have these linked list structures which are like almost 2-dimensional, right? You're linking a linked list into a linked list itself, right? Which is why you might have this type of structure, because again, context, not all problems are just going to have something simple like the head. It might be more complex than that. It is more useful to refer to it as something else. And so that's why you have the availability of different types of structures to solve different types of problems. Okay. So let's have a look. Let's go to the code, actually. That's what I was trying to do. Okay, here we are. We're in the code. There's my whiteboard. I might just... Oh, that did not go as well as I had planned for it to go. Okay. Now my dog is licking himself, so maybe everyone can hear that, which is nice for a Friday afternoon whilst I resize windows. Bit of mood music for you all. Okay, no, here we go. No, I've got this. How many times have I moved this thing? This is so annoying. Here we go. All right, now we're back. Okay, so let's have a look. So we started this ice cream shop. We started this file, icecreamshop.c, and in our file, I've provided a few things. Well, I provided some starter code, and then we're going to keep going. So we include 3 libraries. I'm including my normal library so I can printf, and not that I'm scanning anything in, but if I do, I can. But I'm definitely printing something out to terminal, so stdio. Then I've got this stdlib. That's the one because I know I'm going to need to use malloc, and I know I'm going to need to use free, so that's that one there. And I'm going to use this string one as well because I know I've got a string that I might need to copy in and out of things. And if I want to use anything to do with strings or these special functions, then I'll need my string.h. Okay, so my root structure that we just went over is the struct shop. Inside it is a variable called flavor, which is of type struct ice cream pointer. And this is the head of my list. So this is where I store the head of my list. So which means that to access the head of my list, I will go in the shop structure and into the flavor, okay? And that will give me the head of the list. Okay, then I have my structure that sits inside. So my ice cream structure, which has int number, it has a string, so a char name array, and it's got a struct ice cream pointer to the next flavor. Now this is when I know that this is really a node. And I think, Jeffrey, before you were saying, why not just call it head and call it a day? So it's the same reason as here. This is really a node, but I'm not calling it a node because in this context, I have a different problem and I have a different context to my problem. So I'm calling it an ice cream and it has a few things in it. But I know that it's a node because I can see that there is a next pointer to it. So that means I'm creating a linked list structure. So it's become like a node. Okay, helper functions. I did provide a few. I didn't provide any actually. No, I wasn't that nice. I did not provide any helper functions, but these are the functions that we want to be making. So we want to be making a setup shop function, which is just starting out that very first structure because you start out with no memory. Right? So you malloc the node to have this shop. So you malloc that struct. And what happens is that memory is then sitting in the heap and it persists across your whole program kind of thing. Okay, and then I've got my struct ice cream create ice cream. So that's whenever I create a new node. If you remember when we were creating nodes, this will be synonymous to that. So create malloc some memory for the node and then put some information into that node based on whatever it is that I'm creating. I've got a function to append the ice creams. Now this function will be the function that I use to add ice creams to the back of the list each time. So I'm appending to the tail at the end of the list. And so this function, I won't return anything, but what I'm giving it is I'm giving it my head of the list, which is stored inside the struct shop. And I'm giving it the string and the number that I want to assign to that ice cream. And then I've got print ice creams as well. Also, it is really just a void function because it doesn't return anything. It's just printing, but I'm giving it the head of the list by passing it this struct, the root structure, because inside the root structure is where the head of the list is residing. Okay, and then I'm going to do this insert alphabetical, which is going to be just a barrel of laughs. Maybe you're, yeah. And again, I just give it the head of the list and whatever it is that I want to insert. Okay, so let's see. This is the main function. This is where the magic happens. I think I'm being very, I don't know. Is it where the magic happens? I don't know. Anyway, int main, the usual thing, line 43 is where we're going to start setting up shop. Okay, so the first thing that we do is we create a shop. So a variable shop, did not mean to do that. Sorry, apologies. So we create a variable shop that is a pointer of struct shop type. Okay, so what that means is I'm going to get a node and an address, for the head of the list basically. So I'm going to create this and I'm going to call the function setup shop, and setup shop doesn't take any arguments, which means that I give it an empty, empty brackets because I'm not sending it anything. There's nothing to send it. I have nothing happening yet. Okay, so we go to our setup shop and this function runs. So this function returns a struct shop pointer because it's going to return the address that it has created with malloc. So it's going to give us what address this struct is sitting at. So what happens is on line 62, it creates a struct shop by taking some memory, and what it does is it creates an empty space for us, an empty struct. So once that line runs, it creates this. Inside it will be the struct flavors. And this is called shop because that's the variable name that I gave it. Okay. And now on line 63, I've said shop flavors is null. So shop flavors, I've said that's going to null in there. It's unfortunate. You cannot see what I've said. Okay, and then what I'm doing is I'm returning shop. So what I've done is I'm going to return the address of this shop. And that means that I will always know where it is and how to access it. Okay, so what it does is it returns the address at which this thing was created, this node. It returns the address of it. Yeah, so it returns a pointer to a struct shop. It returns this thing here. And then I can access the pointer inside flavors by saying shop flavor, and that will give me the head of the list. Okay, so what I'm returning is I'm returning this struct shop here. Okay, excellent. So return. So I've returned back to my function, and now I start working. Okay, append ice cream. Okay, so I want to add an ice cream in there. I want to add it to my shop, and the ice cream flavor is cheese, and the quantity is 3. Okay, let's do it. Okay, so now we'll go down to our function. And now we'll go down to our function append ice cream. Okay, here we go. So we've got our function append ice cream. Okay, append ice cream gets the shop, so it gets this memory address here that we know, because that's going to be a way for us to access and place it into the head of the list. It gets the string of whatever it is that we want to place in there and the number. Okay, so right now we're heading in and we've said we want to, the flavor is cheese and the number is 3, and we've given it shop. So we've given it the address of shop. So we've given it the 3 things there: shop, cheese, and 3. Very exciting. So let's now actually do something with it. So the first thing we're going to do is we're going to create the ice cream, because right now we just have those variables, but we really need a node that we can place these things into. Okay. So we're going to run a function called create ice cream, and I'm going to give it the name and the number. Okay. So I'm going to go up to my function create ice cream over here. Okay, I'm creating an ice cream. The first thing I do is I create a new node. Who can see a mistake straight away here? Where I got a bit overexcited. Who can see a mistake in this line? Oh, yeah, well done. That's right. Yeah, I don't have nodes. This is what I mean. It's very, sometimes you get so in the mode of nodes, you forget I don't have a definition for a node. I only have a definition for an ice cream. Exactly. So that was a mistake. Okay. So I'm creating a node of, it's an ice cream. It's called struct ice cream. So I'm creating a node, but it's an ice cream type. I'm calling it new ice cream. I'm going to malloc some memory for it. So what that does is it creates an empty node, and inside it, I've got my name, I've got the quantity, and I'm going to have my next pointer. Okay. So, and this one here is called new ice cream. That's going to be the address of it is going to be in this pointer here. Okay. So the address is going to be inside new ice cream. That's what I've created so that I know how to access it. Otherwise, remember when we malloc some memory, it takes it from anywhere where it can find a big enough space of memory. So otherwise you wouldn't know where on earth it's sitting. Okay, then next I go and I say new ice cream number. So let's say this is my name here. This is my number, if anyone can read this writing, and this is my next flavor. Okay, so new ice cream number is going to be equal to number. So I've passed a 3 in here. So what I'm going to do is I'm going to place that 3 now into number. So that's going to get the 3. Okay. And then remember, we can't just place a string into another string. We've got to use a special function, because in C, a string is just an array of char. So the way to do it, if you didn't have this function, is to copy it character by character, going through the array and then, moving through the second array. So that's why we're saved by this function string copy that allows us to do it with just, calling a function that someone has written that does exactly that. It copies it character by character. So, and it goes destination source. So into new ice cream name, we want to place name. So this one here is going to be copied into there. So that's now going to get this name cheese. Excellent. And then new ice cream next flavor is going to be null, which means that null is going to go inside our next flavor. So that's now pointing to null. And what I return back to the function is I return the address of this node that I've created. Okay, excellent. So I've returned the address of this node that I've created, and this is now sitting inside here. Now I've called them the same thing so as not to make it confusing, but I am just passing around things. Okay, next, if I'm going to append it to the end of the list, if you remember, so I want to be able to traverse the list. And usually when I traverse the list, I have to assign my head value to a temporary pointer that I will use to traverse. Okay. So in my case, what that means is that I'm going to have a current pointer and I'm going to set it to the head of the list. Now remember, the head of the list is inside this shop flavors over here. So that's what I set the head of the list to. Now someone said, doesn't append ice cream need to return a value? That is an excellent question. And the reason it doesn't is because the head of the list is really sitting inside my shop flavors. It's not an ice cream. The struct ice cream is not really the one that's going to be, that's my head. My head is sitting inside shop flavors. But normally if I have just one node kind of structure and a linked list, then they would need to return the head of the list in case I've changed the head of the list. Okay, so then what happens next is we need to consider a few cases. Okay, so one, what happens if it's an empty list? That means what happens if it's the first thing that I'm about to put in there, right? So I can't be traversing a list when there's nothing to traverse. There's no list. So what I'm going to do is I'm going to consider this edge case, and I'm going to say, okay, what if it's an empty list? Then it's really going to be going into the head of the list. The head of the list is going to point to this first element. So I'm going to say if current is equal to null. So remember, we're here in the head of the list. So this one over here, this is my current. Oh, this is a very pretty color. Okay, so if this is my current, okay, is it currently pointing to null? If my current is equal to null, well, it is, because inside this shop flavor, so current is inside here. Actually, I shouldn't have, I've tricked you. Hold on. I got too excited about the pen color. The current is really, let me just fix it up so that it looks more like what it's meant to. Okay, so the current is the head of the list here, and we've set it to shop flavor, which means that my current is this thing inside here. Okay, if my current is equal to null, okay, which means the list is empty, what I'm going to do is I'm going to say change that shop flavor to link into the new ice cream. Okay, that means that I'm going to create this beautiful link here into this new ice cream, and this is no longer going to be equal to null. It's going to be for the address of new ice cream. Okay, then you'll note that what I've done is I've just said return and then just done a semicolon like whatevsies. I'm done here, And that's really what all it means. I don't want to do any more. Return me back to wherever I came from. Okay, I'm done here. So that's all that it means. And that's because I don't really want to then keep going in this particular function. Okay, and that's where we stopped on Tuesday. So now we get to continue this wonderful adventure where we're going to append our ice cream. Okay, so we've now considered the case of what happens if we're inserting into a new list. Great. What about if we have a case where we have multiple, ice cream flavors and we want to go to the end of them? Okay, so what happens if we have something that looks like this? So if we have this one here, and then I'm going to put it here so that you can see it. This one is going to go to this one, and I want to pulse all the way through it to the end and then insert it in. So I want to get to the end of this function first, and then I'm going to insert it. Okay. So who remembers how we traverse a list to get to the end of it? What's going to be our condition in the while loop? I did not mean to make that a comment. Okay, so let's do it. So while, and remember we've got our current. Should we do whilst current is not equal to null, or whilst current next is not equal to null? How are we going to do it if we're appending it to the end of the list? What do we reckon? If we do it current is not equal to null, let's have a look what happens. If current is not equal to null, what that means is when you exit the loop, then current is going to be equal to null, okay? And what that means is that you're sitting over here now, which means that you can't really append anything because you do not know the address of that previous node. That's right. So in fact, we need to stop before it's equal to null, so then we can make the joining happen to the last element. So whilst current next flavor is not equal to null, then we're going to just continue moving across. So current is equal to current next flavor. And that's going to move us along. And what that means is when we come out of this loop, okay, when we come out of this loop, what that will mean is that current next is equal to null. And what it means contextually is that so current next is equal to null, which means that we are standing on the very last node of the list. Okay, so we are like standing on the very last node of the list. We haven't moved anywhere. Okay, so now that we're standing at the very last node of the list, we want to add the node in. Okay, so that means right now that node, if we're standing at the last node of the list, that node is going to be pointing to null. And instead, we want to point it to, so we've got our next flavor. So right now that's equal to null. And we want to point it to the new node that we created. And the new node is sitting inside this new ice cream. So now it's pointing to the address of that new ice cream. And again, I'm just going to return. I mean, it's not really necessary to return here, but just for fun, I've returned because it's going to return anyway because the function is finished. Yeah, that's right. That's it. Perfect. So the address of the next one is now equal to the new ice cream, and we've appended to the end of the list. So that's super duper exciting. Okay. Now let's do this printing, and then we can see what that looks like before we go on to do anything else. Maybe insert alphabetical and delete, and then multi-files. Okay. Excellent. Okay, we've appended an ice cream. Hopefully, maybe Tammy, could you do a poll for me how we feel about adding things at the end of the list, if it makes sense? And let's do a print ice cream whilst we're at it. All right, so for print ice cream, exactly the same way. Okay, you still don't get what's the point of return. There is no point to it over here on line 99 because it's going to finish anyway. That was really just kind of to, just for fun. I just put it in there. So this one doesn't really need to be there. But this one here, because I don't really want to continue looking at anything else in this function if I've already inserted my new node. And that's why, okay, I'm going to return out of this function. It means I don't want to do the rest of it. I'm done here. I feel like this is very applicable to a Friday as well. I'm done here. No. So Stephen, in this case, what's the point of having the struct shop? Indeed, there's not a huge amount of point right now. The only reason I have a struct shop is to show you the same structure as there is in your assignment, okay? But usually I would have more things in that shop and then associated coming out of it as well. So yeah. Okay, so you should return head most of the time because the head of the list is going to change. So you really need to consider what the function is. And if it's possible in your function to change the head of the list, then you should just always return head to be safe. Okay, let's do it. Okay, where was I? Oh yeah, so the printing. Okay, the printing function, it's our normal function. So I'm going to just have a struct ice cream current, okay? So what that means is I want to know where the head of the list is, and the head of the list is sitting inside this shop flavor, or even spelled correctly. Okay, that means I've just set a current pointer to the head of the list. And that's because I don't ever want to lose where my head is. If I start shifting the head over and over, I'll never know where the start of the list is. So that's why it's really important for us to always have this temporary variable to hold the head of the list that you can actually change. So I'm using it as the one that I'm going to traverse the list, and then the head always kind of stays the same unless I change it because something has happened. You know, I'll either insert something at the head or I'll delete the head. Okay, so then I'm going to open a while loop. Okay, this time when I do my while loop, I want to go through the whole list. I don't want to stop at the last element, which means I'm going to say whilst current is not equal to null, which means that I will get through every single element of the list, because when I exit this, I will have current is going to be equal to null. So that means I've gotten through every single point of the list. So whilst current is not equal to null, I'm going to print out my ice cream flavor. So I'll print out my %s, and I'll print out the number as well. Why not? I'll even do a new line so that you can see it look nice. And it's going to be inside current name and current, number, which were the members of my struct. Yeah. Okay. And then of course, unless I want to have the fun situation of an infinite loop, which is always super fun, I'm going to shift my loop onto the next thing. So I'm going to update my loop control variable. So I'm going to update what I'm controlling my loop with. So I've moved it onwards, and that's really it. That will give me this beautiful, function that's everything is making sense. Okay. Yeah, I'll quickly put a comment here. Let's not write a line number in case we're about to change it. Okay, excellent. So we're now appending and we can print it, and we're doing some wonderful things here. So I'm just going to comment this out so that we can print a few things out, and then to see that it all works nicely. Because we're finally at that point where we can print something out. So we've got printing, we've got appending, and we've got creating, we've got the setup. Okay, let's do it. So I'll save it, and now I'll run it. DCC. I always have a quick mind blank on what the file is called every time. Okay, let's have a look. Okay, I've misspelled something on line 63. I've given it a plural because I'm keen to have many flavors of ice cream, but in fact I just have one. Rude. And what else have I done? That's it. Okay, let's save it. Let's try that again. Excellent. Okay, let's clear it, and now let's run it. Okay. And so the ice cream flavors are cheese, dolce, and matcha flavor. So it's appending everything perfectly, which is really nice to see. Makes me feel better. Okay, let's now insert something alphabetically, and then we're going to delete. Okay, so then I want to spend half an hour deleting after the break. So let's do the next 10 minutes to, and then we'll finish up with multi-files, just to give your brains a little bit of a break. Okay, excellent. Let's insert alphabetically. All right, so let's consider inserting in alphabetical order. Where is this function? Here it is. Okay, so what I've given you here is a little hint of how, I've thrown off completely now because I've thrown off the indentation. Okay, I want to insert flavors in alphabetical order. We can use the string compare function to do this, okay? So I've given you a little hint of how this function works. Now, you've used string compare before, I believe, in some of your lab exercises, and we've used it in the lecture once or twice. That doesn't mean that you're familiar with it. In fact, every time I use string compare, I have to look up exactly what it returns, okay? So there is, you know, anytime you use these functions, you will often have to look them up again unless you're using them every single day and you can remember what on earth is going on. So don't worry if you have to look it up. So it returns 0 if the two strings are identical. It returns greater than 0 if the first non-matching character is greater than that of the second string. And it returns less than 0 if the first non-matching character is less than that of the second string. Okay, so what on earth does it mean, right? It means that if I have flavors macadamia and chocolate, it's going to return a greater than 0 because my first string, so the M, is greater than the A, okay? So it's going to return a greater than 0. If I do chocolate and macadamia, the C, I'm sorry, I forgot to, see, I do have issues with my greater than and less than symbols. The C is less than the M because it's, you know, lower down in the ASCII table. And that means it's going to return this less than 0, okay? So it's kind of using that first character to do the comparison. All right. Okay, so we're going to use it in order to insert alphabetically. All right, so let's talk about the logic of what we need to do to be able to kind of do this thing, okay? And it should be, yes, you see, oh my goodness, can't even do, yes, it should be a C, not an A. So it's not just less than and greater than symbols, it's also clearly letters. It's becoming very, very niche now what I can do, which is numbers. And that's it, just code and numbers. Okay, let's have a look. So what will be our logic? What do you reckon? Okay, so we're gonna pulse through this list. Yeah, do you agree? We're gonna go through this list and then we're going to insert when we get to a letter that is something, we're going to insert it in, yeah? So let's do an example of how we're going to do it in a picture, and then we can do it in code. Okay, let's do an example. I'm going to extend this out so that yep, definitely we're going to have a current, absolutely. Okay, I'm going to get rid of this. I'm going to get rid of this. And I'm going to get rid of that just so it's not confusing. Okay, so we've got 3 flavors. We've got cheese, dolce, and matcha. So I'm just going to create those. Okay, so right now we've got cheese. Then we're going to have a dolce flavor. And then we're going to have a matcha. Okay, so that's our list so far, okay? Yes, I am assuming that the list is sorted right now, okay? Because at first I was like, let's sort the list. But then I was like, we don't have enough time in this lecture to sort the list and then insert it. So yes, so I am assuming that the list is sorted right now. That is an excellent question. Absolutely. Okay, so let's say I'm going to insert, and I think I did vanilla. because then I want to show you, oh no, I've got bubblegum. How awkward. Oh yeah, because vanilla would just go at the end. A bit boring one. Okay, bubblegum. I'm going to insert bubblegum. Okay, so if I insert bubblegum, I really want to insert it. Oh, no, I don't want to do bubblegum yet. No, I want to do something simple first, and then we'll talk about bubblegum, because bubblegum, as you can see, will go at the head of the list. It will change where the head is pointing to. So let's do the first one, something between D and M. God. Why am I struggling to think of an ice cream flavor? Yep. Oh yeah, chocolate will do it. Okay, chocolate will do it. Oh, hazelnut. That's a great one. Let's do hazelnut. Thank you. Thank you so much for the suggestions. I've used up all my Oreo flavor. I even have that on the shopping list. I can't believe I didn't think of that. Okay, excellent. Let's do hazelnut, because that will go between the D and the M. Okay, so the hazelnut would need to go in here. Yeah? So what will happen is I'm going to need to scroll through this list until I get to a point where I find the insertion point. I will also need to create my node, won't I? I'll need to create a node for this hazelnut flavor, because right now it's nothing but a string and it'll have some sort of number. So I'll need to create a node, and then I'll want to link it in after D, and this one I'll want to link to the next one, okay? All right, excellent. So if I have my current, and a few people have said, great idea, let's do that. Who did that? Did I do that? I did do that. Okay, so first of all, let's do our struct ice cream current. So let's do our current pointer to move around, and I'll set it to my shop flavor, which is the head of the list. I've not spelled that correctly once today, I don't think. Okay, then what I'm going to do is I'm going to create this node. So I'm going to create that node that has the ice cream flavor in it. So I'm going to create a struct ice cream, new ice cream. And I've already written the function to create the ice cream, haven't I? So that's really nice, because all I have to do now is just say create ice cream for me. And this is the name, this is the number. So what that will do, this line here, is it will create this box over here, and it'll say this is my new ice cream. So then I'll be able to link it in, okay? So hazelnut is pointing to null right now, because what I've done on that line is simply just create this structure. And in my function create ice cream, I just create this node that points to null, and then I will link it up somewhere, wherever I needed to link up. Okay, great. So now I have a node, and I also have the head of the list. So what that means is now I need to search where I need to insert it, okay? So now I start my search, okay? So while current, okay. So there's really two things that I need to consider when I'm searching, okay? What happens if I get to the end of the list and I try to insert? That's going to be a little bit of a disaster. Or what happens if I have to insert it? Oh, you can't see what I'm drawing. That's not useful. Okay, what happens if I need to insert it over here? Okay, so if I say whilst current is not equal to null, or should it be if current is equal to null, then I'll come out here, and that means I'll try to insert there. I don't want to insert there. This is the last possible place that I might need to insert. So that means I want to go until current next is not equal to null. Yeah, so that I can stop at the last node. Okay, and then what I want to be doing is I want to also be considering the case of where I actually need to stop. Okay, so I'm gonna move it in with a string compare. And you know, you could so I'm gonna say whilst that string compare is also going to be what? Okay, so let's have a look. So strcmp. So if I want to insert afterwards, so let's say I've got my hazelnut flavor. So if I go here, okay, so I'm going to insert, I want to insert hazelnut. And right now I have cheese, dolce, and matcha. So it's going to go after dolce. So I want to find the first place where it's bigger than, where it's less than, what am I finding? I want to find the first place. So let's think about the letters. So if I do hazelnut, it's greater than dolce. And hazelnut is less than, is it greater? Oh my God, now I've got my letters issues. Yeah. So I'm going to string compare. And what will I string compare? The name that I'm given. So hazelnut is going to be, great question. What if they start with the same letter? It actually goes through them, and on the first non-matching character, it will return the same thing. So, you know, greater than if the first one is greater than, and then less than if it's less than. Yeah. Okay, so I'm going to compare that, and I'm also going to compare current, next, flavor, and I'm going to compare the name. Yeah? Does that make sense? Is everyone still with me? So I'm going to compare this hazelnut with whatever's happening here. And I want to keep moving, okay? I want to keep moving whilst hazelnut is less than that, yeah? No, more than that. Oh my God. I really wish we could just cancel, less than and greater than. Okay. Is that right? No, I've got an extra bracket now. I do have an extra bracket. Okay, I think that's leaving me without extra brackets. Why isn't it current name? Okay, the reason for that is because I'm trying to see if the next one is the one where, because if I'm going to insert it after it, okay, then I'm trying to see if the next one is going to be less than that. And so if this is the greater letter, then I want to insert it here, kind of thing, okay? Okay, so I'm going to move it across, and then when I come out, that means I'm ready to insert off this while loop. So I'm going to go current, next flavor, and then I'm going to insert it in. So if I'm ready to insert it in, then I'm going to say that my new flavor here is going to go to the next one. So my new ice cream, which is the address of my new node. And the next flavor of that is going to be this one over here. So it's going to be my current next flavor, because I'm stopping one before, remember? So I'm going to go to current next flavor, and then I'm going to link up the current next flavor, and I'm going to make it new ice cream, which is where I link it, this one. So my current here next is going to go here, and then this here next is going to go down to here. Okay, excellent. So let me do that, and we're done. And again, I don't really need to return anything because it's just a void function. Okay, and now let's run it, and we can see what that does. And we can run through it again, don't worry. I know the string comparison does get a little bit confusing, and it's not because you're not understanding what's going on. It's mostly just drawing out the letters to see where on earth they need to go. Okay, so let's run it. It's more important that we do the deletion anyway. Okay, so let's, forgot to save it, and let's run it. And yay, and then I'll do a shop, and then yay, it's inserted it in. Amazing. This is what we wanted to see. All right, let's have a quick break so that you're not fried completely. And once we have a quick break, we will come back, and what we will do is we're going to do deleting. All right, here we go. I'm back. I'm back. I am back. Okay, so 4:15. I still feel it's more important we get through linked list stuff. So if we don't get to the multi-file projects today, which could happen, or we might start it, but if we don't get to the if we don't cover it completely, don't worry, I'm going to record a really short video about it as well. Because really the only place it's used right now is the stage 4 of the assignment. So don't worry, okay? It's more important we get through the linked list stuff. That's the stuff that's, that's the stuff that, that's the magic stuff. That's the juicy stuff. Okay, I see a few people got the riddle. Yeah, that's nice. Okay, let's do deleting. A few people got the riddle answer as well, which I'm very impressed. Yeah, Jeffrey, that's right. So that's right. If you need to insert before the head, it's not going to work. So this is where I was about to bring in the edge cases, because I'm about to break something else for you to show you where edge cases come to happen, come to have fun. So always when you do anything with a linked list, you really have to be like, okay, what happens at the head? Does it change anything? What happens at the tail? Does it change anything? Okay. And those are two of the most common places where people, you always do it for a case where there's something in the list and you've and you have to insert it perfectly in the list, or you have to delete it perfectly from the list, and you have nodes on either side. But the reason you run into these problems when you have a head of the list or the tail of the list is because you don't have nodes on either side. So you might not have, you will have a null piece of memory because there's nothing there. And then somewhere you'll try to access that null piece of memory, and that's when you run into some problems. So absolutely, you are completely correct, Jeffrey. It is going to break because it's not thinking about that one edge case, which is not very nice. We should really be thinking about edge cases. So very good. And we will talk about it more, but see if you can fix it as well. Let's do the deletion, because I really want to go through the deletion and because it will help you as well in your assignment to delete things. Okay. In computer science, do we always have to keep an eye out for edge cases, or is there a way to fix them all in one go? Okay. Oh my gosh, this is such a great question. Okay. So you always have to keep an eye out for edge cases, and you always have to consider them. And honestly, so I worked as a testing engineer for a few years, and that was the fastest way to break a piece of code. I didn't even have to think. The first thing I'd check was the edge cases, and half the time it would break, right? So even, even engineers that, are basically, they've been programming for years, they will still forget edge cases, okay? And it's the most fun to break because it's an easy way to test if something is working. And that's a way for you to also test, if your code is working when you're just running it by yourself, you test the edge cases. And with a linked list, the edge cases are so obvious because it's always the head or the tail, or somewhere in the middle is the perfect case, and then an empty list. So you have these like perfectly set out edge cases that you can think about straight away. Yeah, so my job was to break stuff, which is so much fun. And the more stuff you break, there was people have to buy you lunch and stuff, so it was just free lunch every week. All right, and now now I realize how unpleasant it is to kind of have people break my things, which I don't really enjoy. So now I'm not as gung-ho about breaking things. Well, maybe someone else's things, not my own. But yeah, absolutely. It's fun. It's fun to break stuff. Okay. Let's go back to our code. All right, let's do a prototype for our breaking function. Not breaking function, Freudian slip. Deleting function. We're not breaking things. I wish we were. Yeah, you should break your own stuff so that others don't break it for you. It's true. It's true. You should test your own things, and you should actually be like, it's a really, I know everyone gets really upset when something doesn't work. or when you break something, but it's actually a really positive thing because you've just picked up an edge case and you can program for it then. And, you know, also seeing something break, it makes you realize what can be missing. And so for next time, you'll usually know, what to look out for as well. And that's what I, like. If you have a chance to, spend, a few weeks breaking things, you get very good at knowing what to look out for when you're writing your own code as well. So I strongly encourage you, if you people broke the code that we do in the lectures, I strongly encourage you to run it and just break it a little bit. So yeah, why not? The world's your oyster. Okay, let's do a function to delete. So I'm just going to do a prototype in here. Now, what do we think is going to be the inputs and outputs? What do we reckon is going to be the inputs and outputs for the deleting function? Yeah, input would be the head. Yeah. Oh my gosh, I forgot to switch screens. That is so unhelpful. I'm so sorry. And you can hear me typing. Apologies. There we go. Switched. And the stuff I want to delete. Fantastic. That is excellent. Yeah. So my input would definitely be head of the list and the value I want to delete. Excellent. And what do we think will be my output? And we talked about this on Tuesday when we did deleting. What should be the... Oh, Neil, excellent question. If you delete the head and there are no nodes, do you delete the whole list? It depends on the context of what that question is asking. So maybe the question will be, in this case, I want to shut up my shop. Okay, I want to close the shop permanently. And in that case, I would delete the whole shop. So I'll free that memory as well. Okay. Yeah, excellent. So I will output the head, and that's in case I am deleting the head of the list. So that means I'm going to need to return a new head of the list, because otherwise I won't know where on earth my list starts. Okay. So absolutely, I'll be returning the head of the list. Okay, oh, I forgot to actually write the prototype. I got so excited. We've defined it perfectly. Okay, well, let's call it delete flavor because why not? That seems to be okay. And we're giving it the head of the list, so struct shop, and we're also going to give it the value that we want to delete. So whatever the name of the flavor that we're going to be deleting. Okay. And we've said that we're going to output the head of the list. So we're going to output the struct shop because that's where the head of the list is stored inside there. Okay. Okay, excellent. Let's do it. Oh, should have called it Flavor Town. My goodness. Then I feel like we just have some tunes going or something. Oh, is it tunes going? Okay, let's do it here. I'll paste and we are ready for action. Okay, now this is really going to be very similar to the piece of code that we wrote on Tuesday where we were deleting nodes, okay? So if you remember, we have a few things to consider, okay? Our edge cases are empty list, okay? Then perhaps the head of the list is deleted. Then, it keeps trying to finish what I'm writing, but it's incorrect. Tail of the list, middle, normal, delete. Okay, fantastic. So what's the first thing that we need to do anytime that we need to traverse the list? What is the first thing that we do anytime we need to walk through the list to look for something? What do we reckon? Yep, current, excellent. Yep, we want to create a current pointer that we can use to traverse our list. So let's do that. So we'll do a struct ice cream current and it's going to be pointing to the head of the list, which is currently located. I have not spelled it right once today. I must be just one letter to the right. Oh, to the right. Excellent. Okay, so struct current. Excellent. I've pointed it to the head of the list. Fantastic. Now let's take care of some of these edge cases. Okay, what if it's an empty list? My gosh, letters, not a strong point. Okay, how do we check if it's the end of the list? How will we check if it's the end of the list? What do we reckon? What do we reckon? Yep, excellent. Yeah. So if there is nothing in that list, then my head is going to be equal to null, okay? So if my head is equal to null, that means that there is nothing in my list. And if you remember, then I'm just going to return null, just so that I'm saying exactly what I'm returning, that there is nothing there, so I'm going to return null. So null is still, you know, it's an address of nothing, okay? So I'm returning null, basically, so it's all going to be the same. Okay, excellent. So we've taken care of an empty list. That was a really easy edge case to take care of, wasn't it? Okay, what happens if you have to delete one thing in the list? So empty list, head of the list, where there are no more items or other items. So let's do the head of the list next. Yeah, so you can't delete any stuff if there is nothing there to delete. That's right. So now let's take care of the head of the list, okay? So else if, I'm going to check if the value that I want to delete is sitting in the head of the list, so in the very first node. So for example, if I tried to delete here, if I want to delete this cheese, okay, and it's the very first thing, I'm going to check if the head of the list has the value that I want to delete, because then that means that I'm going to get a new head of the list, okay? So again, I'm going to use my string compare function, and I'm going to compare the name, so the value of the item that I want to delete. So this name here that was passed to it is something that I want to delete. And I'm going to check it against what is sitting inside the current name. And remember that the current is shop flavor, so it's going to be sitting in whatever the name value is over here. That's what I'm going to access. Yep, excellent. Now, if that here is equal to 0, so if this here is equal to 0, that means they match. That means that I want to delete the head node, okay? So that's where I'm going to now do some magic, okay? Yes, it should be. Well done. Okay, so we've got a few suggestions here. So, okay, if I want to delete this head node here, okay, what should I do first? I need to know where the next flavor is so I can pass it on, okay? If I delete it straight up, then I'm not going to know where this node is sitting here, okay? So I can't just go, okay, I'm done here, just delete this node and we're done. Beautiful, done. I can't just do that because I will lose where this node is sitting, and I need to know where this node is sitting. So the first thing I'm going to do is I'm going to save the address of this node. Yep, I'm going to make a temp variable and I'm going to save the address of the node. Okay, so I'm going to make a temporary variable. Oh my gosh, my spelling today is just shocking. Okay, struct ice cream, and it's really going to be the new head because I'm about to delete, you know, the head of the list. And I'm going to put it to this current next flavor, which will give me the address that's sitting inside here, okay? So I've saved this to a temporary variable, okay? Okay, now if I've saved that to a temporary variable, now I can delete whatever my current is. So I'm going to delete, that means I'm killing this node. This node is now gone, okay? Node is gone, excellent. And now I'm just going to reassign the new head to my shop flavor, to the new head. So shop Struggle Town, Struggle Town, Struggle Town. Flavor is equal to the address of the new head. So what that does is I've said this is now gone. This next flavor here is over here, and I'm going to do that now over here. So I've reassigned it. Okay. And I'm going to remember to put a semicolon, and then I'm going to return the shop. So I'm going to return that head back to it. Okay. Why are we using current name and not current? Why are we using current name? Okay, over here you mean, Jeremy? Okay, the reason I'm doing that, I mean, it's really because I'm checking if I'm going to change the head of the list. That's why I'm doing it in this case. And don't worry, I'm going to run the command to check if I've not freed the malloc memory. There are ways to do it without the temp. Absolutely, you can reassign it to the new one. So you can just do shop flavor is equal to current next flavor and then get rid of it. Okay, so you can do it without the temporary variable as well. Yeah. I'm doing it in this way so that it kind of, the series of steps kind of lead to the full story. But yes, you can do it without. Okay, excellent. So now what I really want to do is that I want to be able to, okay, so we've taken care of the head of the list. So now we really want to do that normal case where something might happen or something might not. And I will demonstrate the leak check, okay? Once I run this, I'll demonstrate how to do the leak check as well. Okay, now let's get to the end of the list, okay? Let's do it. And I'm going to, this might not, okay, it will compile, but it might not be perfect. That is so that we can see an edge case in action, okay? Okay, so I'm going to string compare and find this node that I want to delete. So what I'll do is I'll string compare the node that I want to delete, and I'm going to do it the next node over, because remember, I always want to be standing on the previous node because I don't want to lose the address of it when I'm deleting, okay? Okay, and then I'm going to go to name, so I'm going to compare them. And if they're not equal, oh gosh, okay, if they're not equal to 0, that means I'm going to keep going, okay? So what that means is I'm going to move across until I find the node that I want to delete. It's going to be the next node, and I'm going to be standing on the node before the node that I want to delete, okay? So whilst current is equal to next flavor. So when I come out of here, what that means is that my next node is going to be the node that I want to delete, okay? It's going to be the matching node. All right, excellent. So again, what I'm going to do is I'm going to now do the deletion. So again, I'm going to do it in a similar way as I did above. So what I'll do is I'll create a temporary variable to store, so it's going to be my new next, and that's going to be equal to current next flavor and next flavor again. Now, does it make sense why? So let's have a look and I'll show you why. Okay, so let's say that what I am deleting is, okay, let's say what I want to delete is sitting over here. Okay, let's say I'm still on an eraser. Okay, let's say I want to delete this one here. Now, my current is going to be over here, and this is my current next. And if you remember, the reason we did it like that for deleting is because if I want to delete this current next, I need to know where my previous node is. Otherwise, I will lose where I'm going to go. So what that means is I want to assign my current to this next node because I want to bypass this middle node before deleting it, okay? So what I'm going to do is I'm going to I'm going to do next flavor, which means that I'm going to go not this one, but the one after it. So what I'm creating is this link here, this blue line here, where I'm bypassing the node that I want to delete. Okay, excellent. Now I'm going to delete that node. So I'm going to free the current next. And then I'm going to say that means that my current next flavor is going to be equal to this new next. Okay, so what I've done is I've created this blue line link here. Okay, all right, excellent. And that's it. And then I'll return the shop. Okay, so I'll return the shop, which is the head of the list. Okay, let's save it. And I'll show you what happens. And let's use, because we're using the free command, I'll show you the leak check now as well that you can compile with. So let's just make sure that we're calling it here. So we're going to print this ice cream shop, and then I'm going to call my delete flavor. And I'm going to delete, in which order did I have it in? The shop was first, okay. Delete flavor from the shop, and let's delete Dolce. And then to check, we're going to print the ice creams again. Okay, let's see. Okay, so now when I compile, if I want to leak check, okay, I'm going to DCC, and then I'm going to do leak check command. Either like this or like this, doesn't matter, okay? Now, what that will check is that every piece of malloc memory has been freed, okay? And in our case, it's not going to be because we haven't freed the shop, which we malloc some memory for. But it's useful when you are deleting everything, and useful in your assignment as well for the case where everything is being deleted as well. But it also lets you see if there's anything that you're missing. Okay, so leak check, and then you just do as normal. So ice cream shop.co shop. Okay, and let's run it. Excellent. After all that, I've forgot to do flavor here. And Kritika, you asked, what does current next flavor name mean? What that means is current. So if I'm currently here, yeah, current next flavor, that moves me over to this branch, and the name is this one here. So I'm accessing the name member of that. So you're dereferencing it and dereferencing it onwards to the next one. Okay, let's move on. So let's compile again. I forgot to save it. My goodness. Not having a good day. Here we go. Okay, now we're compiled. So I've run that leak check command when I compiled it, and now I'm just going to run it. Okay, so when I run it, what it will do is it will give me my flavors, okay, which was cheese, blah, blah, blah. Okay, then notice after I deleted the Dolce, it's given me no problems. And this is what happens when you run that leak check command, is it says error. Free, not called for memory allocated with malloc in function setup shop in ice cream shop.c. Okay, so what that means is I have malloced some memory in my shop over here, and I have never freed it. Okay, so it's never been freed. So it's letting you check that every piece of malloc memory has been, is gone. Okay, excellent. So that's that leak check command. All right, fantastic. That seems to be working. Does everyone think everything is working, or should we break it? Should I break it for you? Break time? Breaking time? Not break time. Breaking time. Should we break it? What do we reckon? How do we feel? Jeffrey, that's correct. So when you finish running your program, you should really free the shop. Okay, let's break it. All right. Over here, what I'm going to delete is how do we think we should break it? What do you reckon? We took care of the head of the list. We didn't really consider the tail, did we? So to break it, I'm going to delete the tail. Okay, so I'm going to delete matcha. Let's see what happens. All right. Let's see what kind of magic occurs here. So compiles, no problem. Okay, excellent. All right, and let's run it. And let's see it tell us nothing. Ah, because hazelnut was at the tail of the list. How does that make sense? Did we not link something incorrectly? Okay, let me break it like this. Okay, we clearly something didn't work quite as... Okay, let's break it. Here we go. Compile, break. What is happening? I can't seem to break it. How is this happening? What have I done? Which magic have I done? I should have broken it. This is just madness. What is happening, honestly? Okay, what am I? I'm going to delete. No, it's definitely not perfect. Let me try this again. Break. That's actually a meme, you know, when code works and you don't know why. It should be breaking. I cannot believe this code. How dare it? How dare it do what I want it to do? This is an absolute outrage. This is unbelievable. No, the leak check is definitely not stopping it from breaking. And honestly, I did this yesterday and I broke it completely and utterly. This was the specific reason why I wanted to do it. Yeah, let's have a look at the delete function again, because it shouldn't be performing so well. Where did I take care of this case? Okay, if current is equal to null, return is equal to null. Okay, that's nice. Here I've checked if the first thing and I've changed the head of it. Okay, that's nice. Okay, and then we have then we're comparing it. I must break it. It's bothering me now. Okay, I'm going to break it and then I'm going to post on announcements how I broke it, I think. But this should really have broken. This is just... It should have broken when I deleted the head. Because what if... It's because I'm going for the next one, then I'm moving on to the next one. So every time I'm coming out... Yes, that's right. Yes, that's right, Lewis. Current next should be null. That's why it's really... That's correct. Yeah. Making up for all the typo. I don't think I can ever make up for that. I do so many typos, it's ridiculous. Okay, all right, okay. Tammy, could you please run me a poll? How is everyone feeling about linked lists? How is everyone feeling about bringing it all together in linked lists? How is everyone feeling? I will break it. I will break it. Can we go through the code line by line from line 165? We can if you like, of course. You mean this section here, okay? Yeah, and right now it's looking like the coder will be broken, not the code. Okay, let's have a look. I'm going to just shift this slightly. Oh, so I was hoping to do like a big debugging, like a linked list, the problems that you get with linked lists, because they're very specific, and I've seen a few people have had segmentation faults as well on the forums. I am looking on the forums. I don't answer all the time, but yeah, so it would be good to go through some of those issues as well. Yeah, I agree. So maybe that's something that we can set up for week 9. Tammy will remind me that that's something, and then, you know, we can go through all the common issues you get when you do linked lists, and it's just going to be the head, the tail, you know, seg fault, not freeing everything, and things like that. Okay, so line 165 onwards, okay? Line 166, easy, nothing's happened. I'm very pleased with that line, okay? Then in line 167, let me actually just clear this list so that it doesn't have all the circled things on it. Let me just clear this. Okay, so what you have is your current, okay, so whilst it's not equal to, let's say I was deleting the Dolce one, okay? So that means that my current is here, and this is my current next. And this is my current next over here. So this one is the next. Okay, so if I've come out of here, what it means is that my string compare is equal to 0 for this current next flavor name. So current next flavor name is the one that I want to delete, so I've stopped here. So this is the point at where I came out of the while loop, let's say. Okay, I've come out of the while loop. The next thing I'm doing is I'm saying, inside a pointer new next, I'm going to store current next flavor. So because I'm going to be getting rid of this node over here, I want to store the address of this node here because I won't be able to access it once I delete it from here. So what I've said is that this node over here, my current next, so my current is here, so next and next, this is going to be now my new node, or new next. What did I call it? New next. So this is my new next. That's what I've said here. Nothing else has happened. Then what I've done is I've freed the current next flavor. So I'm freeing this current next. That means I'm getting rid of it. Goodbye memory, goodbye, it was nice to see you. And then I'm saying current next flavor is equal to new next. So this current next is now going to be pointing to the new next, so to this one. So that's what I did in those 3. Yeah, it is. This is why my code works. That's right. I'm never accessing because I'm always keeping one back. Yeah, that's right. Otherwise, I would hit the null and then I'll dereference a null and it's all over. So nice. Yeah. Okay. Excellent. And we still have a few minutes. Maybe 10 minutes to start our multi-file projects. Should we try and do multi-files in 11 minutes? How's everyone feeling? It depends how you program for tail. So it depends on how you make, so there's a number of ways how you can do the delete function, right? And that's, yeah. Okay, everyone's feeling burnt out. Yeah, so again, the tail sometimes needs to be a special case. You always need to check, okay? You always need to check if your code works for the tail, okay? Multi-files are used in stage 4 of assignment 2. So it's not like a necessity for us to do them today. Okay, so there's That's the real edge case is if you have an empty list. The real edge case because you have null, and then whenever you try and run these types of commands where you're going current next, it's going to go and then you're dereferencing it into name, and that's inside null, okay? So you're going to come into issues. So you really should be very, check the head, check the tail, check if it's an empty list, and then check the perfect, situation where you're in the middle of two nodes and you're just going to beautifully remove, connect, magic, okay? Okay, everyone's like, okay, everyone I think is feeling more to do it, okay. If everyone is feeling more inclined to do multi-files next week, then that's okay. We can do that. We can do a quick multi-file and then we will talk about what a stack is. Yeah, so I could also, yeah. So Darren, that's right. So I could also be checking that I'm not going past the end of the linked list when I'm looking for things. That's why I'm so surprised. I'm still trying to, I should be able to break it. I just need a minute to draw it out again. Oh, Jeffrey wants to do it today. Oh my goodness. What a push. Let me go over some of the logic today. We can go over it again on Tuesday. All right, let's just go over how it works, okay? Okay, so you have something called multi-file projects, okay? Don't be worried. It's not that bad. I promise you. All it is we are human. We cannot read huge amounts of information. So we've come up with this way to be able to break up our files. It makes them more readable. But also there are other benefits in that you can separate code by a certain category, or you can also have different people working on different modules and then you bring it together, okay? So it's, there's a few reasons why we have these types of multi-file projects, but mostly it improves readability by quite a lot, and then in larger projects, multiple people can work on them. So we have actually been using multi-files already without you knowing. Every time you hash include something, you're using a different file, okay? It's just that file has been provided to you by C, okay? So you're actually already using multi-files without even knowing it. It's like when you were using scanf and pointers and you didn't know it, that your life was about to change when you found out what on earth the ampersand means. So now the same, but this one is not as bad a change. Pointers, I feel, is a much more rough change to your life as opposed to multi-file projects. So far we've only been including the C standard libraries, but you can also hash include your own libraries, which is so fun, so exciting. You can be completely in charge and in control, you've got your own libraries, you can make things happen. And what it allows us to do is it allows us to join projects together. It also means that multiple people can work together on projects in the real world. What that means is if I've produced a module, let's say I've got a whole file of just things that do stuff to strings, I can just plug it into a different project that might want to do something with strings. And what that means is I don't have to rewrite all those functions. I have access to them. And that's really what C standard libraries do. Everyone all over the world is using the same C standard libraries, okay? And that means that you're able to use all these pieces of code and all these functions that have already been done, and you just use them. Okay, so in a multi-file project, what we have, I know everyone is struggling. I know, just 2 more minutes, okay? 2 more minutes, and then we'll actually put it into action on Tuesday. Yeah, that is the day of the lecture. I've got this. Okay, so you might have multiple header files, or you might have one header file. It depends what you're doing. Just like in our, in our hash include, we can include multiple H files, and those are called header files. So the .h files is the header files. Yeah, Neil, that's right. So you could have a whole file that just makes new nodes and does things with linked lists. Okay, you could have like a linked list header, And that's the header that you include anytime you want to implement, creating a node. And then you just run things from your main and just, and then just, have fun with it. Okay, so you might have multiple header files. Those are the .h files. And then you might have multiple implementation files. So you might have a .h file. That's where you will list out what is actually going to happen. So you list out all your function prototypes and all your comments. And then .c file is where you make it happen. So your header file might have prototypes of some functions, and in the related .c file, that's where you make those functions happen. So that's where you actually implement them, implement the code for them. And then you might also run a main.c file, and that main is just your int main void. So it's just you calling all the functions, and that's it. So if you remember up till this point, I've been saying to you, you really want to have your main as something really nice. You don't want any logic happening in the main. You really just want to be calling functions from the main. It has to be and that's kind of the purpose of this. The main should be able to be used with a variety of different implementation files where you're just calling functions, because you might have different people working on different implementation files. Now, if you are including your own header file, so if you remember with the .c ones, you use a greater than and less than symbol. When it's your own, you use inverted commas, okay? So you hash include and then you put it in inverted commas as your .h file. That's when it's your own, okay? So typically that is including all of your function prototypes that you will implement in the implementation file, and it will also have the comments for how those functions work, okay? Any hash defines go in the header files, and basically this is like your spec. This is the file you give to the programmer and you tell them, this is what I want to implement, go to town, okay? And it will have your function prototypes, so they'll know exactly what the inputs and outputs are of the function, and it will have the comments for what each function should be doing. And then someone should be able to implement those prototypes. So the file shows the programmer what they need to know to use the code. There's no running code in the .h file. It's a definition file. It's your header file, okay? So it's the one that defines it all. And then your implementation file, that's your something.c file, and that's where you implement the functions that you've defined in your header. And then the main is where you will call all of those, okay? So usually you have three files: the header file, the implementation file, and also your main.c. So all your .c files should include the header file. The header file doesn't have to include anything, but inside any .c file where you will use that, you'll include the header file. Okay, and we will discuss it with the proper example, with a proper example on Tuesday. And then when you compile it, you compile just your .c files, and you might have seen this in your assignment. You can compile a number of .c files. You don't ever compile the .h files, just the .c files, and you have to compile them all for it to work. No, we do not learn header guards, but yeah. Okay, we're going to finish there because that's perfect timing, and then we're going to do an example, a really basic example on Tuesday before we do stacks. And feel bad saying I love stacks, but I love stacks. I feel like I love linked lists, and we're going to do it with a linked list, so you get more practice with linked lists, okay? So more linked lists coming to you on Tuesday in a slightly different kind of movement. But thank you so much for tuning in on a Friday afternoon. I know it's always a challenge. I really appreciate it. I appreciate all the questions as well. It's been great. Lots of people thinking about the different ways that we can break things and make things, and keeping it engaged as well. Thank you so much. And I look forward to seeing you on Tuesday. I hope you all have a wonderful weekend. Hopefully it's not pouring with rain and you get to go out and enjoy something. So, yep, I've malaked your brain cells, and I haven't freed them yet. 2 more weeks before I can free them. So have a good weekend, and I'll see you all next week. Bye, everyone. Oh, I forgot to say, if you have any feedback, please leave it, because I forgot to do it on Tuesday. Thanks, everyone. Bye.